Hello and welcome to our class. Today we'll talk about mensuration. So what is mensuration? Mensuration is the branch of mathematics that studies the measurement of geometrical figures like volume, area, perimeter, etc. In this chapter, we'll focus on how to calculate the area of all the geometric shapes we learned so far. What we learned today is area of a rectangle and square, area of a triangle. Then we do a bit of practice. First, area of a rectangle and square. Before we start, what is area and what is perimeters? So we have the rectangle ABCD here. The area is the yellow part, which is within the shapes, is the space inside the shape, and when perimeters is the red line you see here is AB, BC, CD, and DA. Is the path or the boundary that surround the shape. So, example 1. Given a rectangle with dimensions 8 centimeters by 5 centimeters, calculate its area. So to do this, we'll divide the rectangle into unit squares. So how many squares will we have? Let's see the figure here. So there's 8 squares in a row and 5 squares in a column. So we just have to sum it up. So there will be 40 squares, which is 8 times 5. And notice how 8 is the length of the rectangle and 5 is the width of the length of the rectangle. So we have the formula S equals length times width. Moving on to square. Square is similar to rectangle, but there's one special thing about it is its length is equal to its width. So how can we calculate it? We will use the formula we learned about earlier. The formula to calculate the area of a rectangle. But now we used it with length equal to width. So S equal to length times width, which is equal to length to the power of 2 equal to width to the power of 2. So we have a formula for calculating the area of a square is S equal to side times side, which is equal to side to the power of 2. Let's do a bit of practice here. Example 2. Given a square with dimensions 5 centimeters by 5 centimeters, calculate its area. So since we already have the side here, we just simply follow the formula, which is S equal to side to the power of 2, which is 5 to the power of 2 equal to 25. So the square's area is 25 square centimeters. Moving on. 2. Area of a triangle. So before we start, we'll go to a more specific case. Here is area of a right triangle. So we already know the area of a rectangle is S equal to length times width. So, but can we calculate the area of the right triangle ADC as given here? Notice how this triangle is half of the rectangle ABCD. so its area is also half. So we have area of triangle ADC is equal to 1/2 of AD times DC. Now we have our general formula theorem. The area of a triangle is half the product of its base and its corresponding height. S equal to 1/2 of A times H. Now to prove this, we'll consider three cases. Cases number 1. B and H are coincide. So since, notice here, when B is coincide with H, the triangle is the right triangle. So we can use the formula we have earlier, and we have S equal to 1/2 of AB times BC, which is equal to 1/2 of A times H. Case number 2. H is between B and C. So in this case, we can divide the big triangle ABC to two smaller right triangles, which is AHB and AHC. So, and since we already know how to calculate the area of a right triangle, we should have to put in is 1/2 of AH times BH plus 1/2 of AH times HC. And since BH plus AC is equal to BC, so the area of the triangle ABC will be equal to 1/2 of AH times HBC. 1/2 of AH times BC, which is equal to 1/2 of A times H. Case number 3. H is outside of BC. Now look at the big triangle here. It is ABH, right? And you see that it can be divided to two triangles ABC and AHC. So to calculate the area of the triangle ABC, we can do like this. It will be the area of a triangle ABH minus the area of a triangle AHC. And since we already know how to calculate the area of a triangle, of a right triangle, we get this: 1/2 of AH times BH minus 1/2 of AH times HC, which is equal to 1/2 of AH times BH minus HC. And since BH minus HC is equal to BC, we have 1/2 of A times H. Now let's go to the practice. Exercise 17. Given triangle AOB right at O with altitude OM. Explain why we have the equality AB times OM equal to AOA times OB. So since AOB is a right triangle, we have the formula for the which is 1/2 of AO times OB. But right triangle is still a triangle, right? So we can use AB as the base, and we use the formula for right triangle, which for a triangle, which is 1/2 of OM times AB. And since these two is equal to area of a triangle AOB, it will equal to one another. Multiply the two sides by 2 when we have what we need to explain. AB times OM equal to OA times OB. Exercise 18. Given triangle ABC and median AM, prove that area of a triangle AMB is equal to area of a triangle AMC. So first thing we do is draw the altitude AH. Now what is the area of the triangle AMB and AMC? It will be 1/2 of AH or times BM and 1/2 of AH times MC. So notice here that AM is a median, so BM is equal to MC. So and since BM is equal to MC, we get 1/2 of AM times BM is equal to 1/2 of AH times MC. So area of a triangle AMB is equal to area of the triangle AMC. So what we learned today? We learned that area of a rectangle is A times B. Area of a square is A times A, or A to the power of 2. And area of the triangle is 1/2 of B times H. Thanks for watching.